Welcome to Sleep Quotes Lab. You made it. Now you can let go. Let the noise fade. Let your breathing guide you. And let these gentle words keep you company as you ease into sleep. Tonight, we're not just learning about space. We're discovering something unsettling. The galaxy you call home is not what you think it is. It's been hiding things from us. Violent collisions we never witnessed. Stars that shouldn't exist where they are. A past written in scattered light that nobody taught you to read. The Milky Way has secrets, and some of them are strange enough to make you question what home even means when you're spinning through a cosmos that refuses to stay still. Let your breathing slow. Let your body sink deeper. Because what you're about to hear might shift something in how you see the night sky. And by the end, you'll understand why the stars you've been looking at your entire life are not permanent, not safe, and not even close to telling the whole story. The Milky Way has already been in a collision, and it's headed for another one. You might think of our galaxy as stable, unchanging, but it's built from wreckage. Over billions of years, the Milky Way has consumed smaller galaxies, pulling them apart star by star, leaving behind ghostly streams that wrap around the disk like ribbons of memory. Right now, at this very moment, a dwarf galaxy called Sagittarius is being torn to pieces, and far off in the darkness, something much larger is approaching. Andromeda, another spiral galaxy, drifting closer at hundreds of kilometers per second. In about 4.5 billion years, the two will merge, not violently, not with explosions, but slowly, gracefully. The stars won't collide, they're too far apart, but the shapes will twist, warp, fold into something new. A galaxy, neither Milky Way nor Andromeda, but something else entirely. Even galaxies, it turns out, are not forever. Some stars in the Milky Way are older than the Milky Way itself. That sentence doesn't make sense at first. How can something inside a galaxy be older than the galaxy? But it's true. Scattered through the halo, moving in long tilted orbits, are ancient stars that appear to have formed before the Milky Way even took shape. Astronomers believe these stars came from smaller primordial galaxies that merged with ours billions of years ago. Their chemistry tells the story. Almost no heavy elements, just hydrogen and helium, the ingredients of the very early universe. They move like elders above the galactic plane, carrying memories of a time before spirals, before structure, before anything resembled order. In their light, we see an earlier universe, one still learning how to become what it is now. Our solar system is racing through space at over 828,000 kilometers per hour. And even at that speed, it takes 225 million years to complete one orbit around the galaxy. Think about that. One lap, one circle. 225 million years. That means, since the solar system formed, we've only orbited the Milky Way about 20 times. When dinosaurs first appeared, we were in a completely different part of the galaxy. The stars you see tonight weren't always nearby. They won't always remain. Everything is in motion. The Earth spins, the moon circles, the sun sweeps forward through a galaxy that never stops turning. Even as you sleep, you are traveling, silently, endlessly. The galaxy is still growing, It's ancient, yes, over 13 billion years old, but it's not finished. Even now, it continues to gather material, gas from the space between galaxies, stars from captured dwarfs, streams of dark matter feeding its invisible halo. Some of this growth happens quietly, through slow infilling. Other times, it's violent. Satellite galaxies torn apart, their stars scattered like seeds across the sky. The galaxy you live in today is not the same one the dinosaurs knew, and the one your distant descendants may inhabit could be larger still, stitched together from the ruins of 1,000 smaller worlds. We don't actually know how many spiral arms the Milky Way has. It seems like something we should know. How many arms spiral out from the center of our own galaxy? But from our position deep inside the disk, buried among the stars and dust, it's hard to see the whole picture. For decades, astronomers thought there were 4 major arms. Then more recent observations suggested maybe fewer, or maybe the arms twist and split in ways more complex than we expected. Some fade into fragments, others wrap around unpredictably. The Milky Way may not be a neat pinwheel at all. It might be something messier, more alive, a layered swirl shaped by forces we still don't fully understand. Rogue stars are flung from the core at astonishing speeds. Most stars drift calmly through the galaxy, but a rare few are ejected outward fast enough to escape entirely. These are hypervelocity stars. Some are remnants of binary systems disrupted by the supermassive black hole at the galaxy's heart. One star falls in and vanishes. The other is slingshot outward, hurled into the dark at over 1 million kilometers per hour. These rogue stars travel alone, far beyond the galactic plane, like glowing comets with no return. They remind us that even in a galaxy bound by gravity, there are moments of violent release, quiet expulsions that send stars flying into the night between galaxies. The Milky Way and Andromeda are on a collision course. High above the horizon, Andromeda appears as a faint blur, a spiral much like our own, lying over 2 million light-years away, and yet it's moving steadily toward us. In 4.5 billion years, they'll collide. Not violently in the way you might imagine. Stars are spaced too far apart to crash directly, but gravity will warp both galaxies into long stretching arcs. Tidal tails will curl outward. Black holes may spiral together. And after billions of years, the two will merge into a single, larger system. A slow, elegant dance. The future of our home written across the stars. Some stars orbit backward. Most stars in the Milky Way orbit the center in the same general direction. But not all of them follow the rules. Some stars, especially in the outer halo, move in retrograde, orbiting opposite to the galaxy's main rotation. These stars likely arrived from elsewhere, born in dwarf galaxies that were later absorbed. Their reversed motion is a quiet signature of their foreign origin. It's as if the galaxy carries old memories in its motion, stories of ancient mergers and cosmic encounters preserved not in light, but in the slow, patient turning of stars against the stream. The Milky Way may have eaten dozens of dwarf galaxies. Over billions of years, the Milky Way hasn't grown alone. It has consumed small galaxies, faint companions drifted close, were caught in its gravity and slowly dismantled. Their stars are now part of our halo, our disk, our stellar streams. Astronomers have identified several of these mergers by analyzing stellar motion and composition. One especially large event, the Gaia-Enceladus merger, added countless stars and may have reshaped the early structure of the galaxy entirely. The Milky Way is not a pristine spiral. It's a composite built from quiet collisions, stitched together from the remains of many smaller worlds. The chemical makeup of stars reveals their origin. Every star carries a unique chemical fingerprint, a pattern of elements imprinted at birth. By studying these signatures, astronomers can trace a star's history. Some stars are rich in heavy elements like iron and calcium, suggesting they formed in dense metal-rich regions. Others are nearly pure hydrogen and helium, born when the universe was still young. These differences allow scientists to group stars into families, uncover ancient mergers, and reconstruct the hidden story of the Milky Way's formation. Chemistry becomes a kind of time machine, letting us read a star's past like a line of ancient poetry written in light. The sky is full of stellar streams from shredded galaxies. Across the sky, thin ribbons of stars stretch in arcs and curves, barely visible but unmistakable when mapped with precision. These are stellar streams, the remnants of smaller galaxies that wandered too close and were pulled apart. As they orbit, their stars are smeared across space by tidal forces, forming long, delicate trails that trace their former paths. Some wrap around the galaxy like ghostly halos. Others dive toward the core. These streams are evidence of past collisions, quiet mergers that built the Milky Way over billions of years. The galaxy, like a tree, carries the rings of its past in every thread of light. The Milky Way is warped. Our galaxy doesn't lie flat like a perfect spiral. Its disk bends upward on one side and downward on the other, forming a graceful wave across the stars. This subtle warp was invisible until radio telescopes mapped the hydrogen gas stretching far beyond the starlight. Astronomers believe the distortion may be caused by satellite galaxies tugging gently on the edges, or by clumps of dark matter bending the structure from below. Like ripples in a great spinning sheet, the warp reveals that even galaxies are never fully still. Over time, they bend, flex, and change form in response to invisible forces. From a distance, the Milky Way might look like it's dancing slowly through space. You can only see about 0.00003% of the Milky Way with the naked eye. Under a clear, dark sky, far from cities, you might see a few thousand stars. To the human eye, that seems like an ocean of light, but it's barely a droplet. The Milky Way contains over 100 billion stars. Most are hidden. Some lie behind thick curtains of dust. Others are too faint or too far away for our vision to reach. The pale streak that crosses the sky on moonless nights is just the innermost whisper of the whole. We live surrounded by a colossal river of starlight, and yet almost all of it remains invisible to us, too vast to grasp from within. Stars orbit the galaxy at different speeds. Unlike planets in a solar system, which follow neat tracks around their star, stars in the Milky Way move with more freedom. Some race ahead in the inner regions, others drift slowly along the outskirts. This difference in speed is why spiral arms form. They're not solid structures, but patterns, like slow traffic jams of stars and gas moving through space. As these density waves pass, they trigger new stars to form, lighting up the arms in curls of blue and white. Our own sun is part of this swirl, moving in and out of these patterns across time. The galaxy is not a clock. It is a current, and we are drifting in it. The galaxy holds together because of something we cannot see. The Milky Way's spiral arms are not simply made of stars. They're woven from the birthplaces of stars. Giant clouds of hydrogen, dust, and molecules drift through the galaxy. And when these clouds pass through the spiral arms, they're compressed and set alight with newborn suns. These regions are called stellar nurseries, chaotic, glowing, full of motion. Ultraviolet light from new stars illuminates the clouds, painting the arms with radiant blues and silvers. These bursts of creation trace out the spiral shape, illuminating the curves of the galaxy with quiet fire. Every star, even the sun, was born from one of these cloudy cradles long ago. The Milky Way is surrounded by a vast halo. Beyond the flat spiral disk lies something far more diffuse, a spherical halo that surrounds the entire galaxy. It contains ancient stars, globular clusters, and enormous amounts of dark matter. Though nearly invisible, this halo may hold the majority of the Milky Way's mass. Its stars are spread thin across vast distances, orbiting in long, slow arcs that rarely touch the disk. The halo also preserves the remnants of ancient galactic mergers, streams and shells of stars torn from smaller galaxies and left behind like cosmic fossils. It is the galaxy's outer memory, quiet and dim, but still in motion, still shaping what the Milky Way becomes. It contains over 150 globular clusters. Globular clusters are among the oldest objects in the galaxy. Compact spheres made of hundreds of thousands of tightly bound stars. They orbit the galactic center in the halo like moths circling a distant flame. These starless clouds float through the galaxy like silent possibilities, rich in molecular hydrogen but untouched by fusion. They may one day ignite, or they may drift until torn apart by external forces, their gas recycled into other regions. In these clouds, the galaxy holds its breath, waiting, perhaps, for the right nudge to spark something new. The Milky Way recycles matter across generations. Stars are not permanent. They live, burn, and die. And in dying, they return their material to the galaxy. Supernovae spread heavy elements. Red giants shed outer layers. Planetary nebulae drift outward into space. This enriched material joins the interstellar medium, where it cools, condenses, and eventually forms new stars, planets, and even life. Every atom in your body has passed through this cycle, born in a star, scattered into space, gathered into new form. The Milky Way is not a static stage. It's a great engine of renewal. It breathes in time with its stars, making, unmaking and beginning again. Not everything in the Milky Way follows the neat plane of the disk. Some clouds of gas and even some stars move in highly inclined orbits, passing above and below the galaxy's main structure. These polar orbits likely come from past mergers, when dwarf galaxies or stray clouds were captured at odd angles. Over time, they've continued to orbit on tilted paths, like comets around a planet. These misaligned orbits are records of disruption, visible reminders that the galaxy is not a closed system, but an evolving structure shaped by the unpredictable flow of cosmic history. Giant shells of gas surround past starbursts. In several regions of the Milky Way, astronomers have found enormous spherical shells of gas, some spanning hundreds of light years. These shells are the remnants of powerful starbursts, episodes when clusters of massive stars formed together, lived brief lives, and exploded in rapid succession. Their combined winds and supernovae carved out huge cavities in the interstellar medium, blowing gas outward in all directions. Over time, the expansion slows, but the shells remain, ghostly bubbles marking where the galaxy once burned bright with stellar birth and death. These are the fossils of cosmic fireworks, still echoing in the cold. Stars occasionally collide in dense regions. Space is vast and stars are small, but in the densest regions of the Milky Way, such as the cores of globular clusters, stars can pass close enough to interact and even collide. When they do, the result can be dramatic: a burst of light, the merging of two suns, or the formation of a rare blue straggler star, one that appears younger than its neighbors. These collisions are rare, but not impossible. Over billions of years, the tightest stellar neighborhoods can rearrange themselves through gravity and chance. In these crowded stellar cities, time moves differently, and space is never quite empty. Binary stars can be torn apart by tidal forces. Many stars live in pairs, orbiting each other in gravitational embrace. But even this bond can be broken. If a binary system passes close to the Milky Way's central black hole or through a dense cluster, tidal forces can disrupt their orbit, flinging one star away while the other is captured or slowed. In some cases, a companion is hurled out of the galaxy entirely, becoming a rogue star speeding through intergalactic space. These stellar breakups happen silently, in places we rarely see, a quiet tearing of ancient partnerships by gravity's indifferent hand. Some stars escape the galaxy entirely. Most stars are gravitationally bound to the Milky Way, but occasionally a star reaches escape velocity, over 500 kilometers per second, and is flung outward, never to return. These hypervelocity stars are rare, but real. Some are thought to be ejected by interactions with the supermassive black hole at the galaxy's center. Others may be slingshot by three-body encounters or supernovae in binary systems. Once free, they travel alone into intergalactic space. Tiny lighthouses drifting far beyond the spiral's edge, they carry the galaxy's memory outward, becoming solitary pilgrims in the great dark between galaxies. The Milky Way contains stars from other galaxies. Not all stars within the Milky Way were born here. Some may have originated in other galaxies, captured during mergers or flung into our halo from distant regions of the local group. These intergalactic wanderers often move on unusual orbits, far from the disk, tracing paths through the outskirts or halo. They can be identified by their composition or motion. Stars that don't quite fit the local patterns. Like cosmic immigrants, they bring stories from other environments, other histories, other skies. The Milky Way is not a sealed system. It is a living mosaic, slowly stitched together by time and motion. There's a fountain of gas cycling between the disk and halo. Above and below the Milky Way's bright disk, gas rises and falls in a quiet loop known as the galactic fountain. Supernovae and stellar winds heat and eject material upward into the halo, where it cools, condenses, and gently rains back down over millions of years. This cycle stirs the interstellar medium, redistributes heavy elements, and helps regulate star formation. It's a quiet respiration, a breathing motion of matter between the dense plane and the vast halo. The galaxy, in this way, doesn't just spin. It circulates, it exhales and inhales, keeping its structure in motion across immense spans of time. The galaxy's dust grains carry organic compounds. Within the clouds of interstellar dust that drift between stars, scientists have detected complex organic molecules, carbon-based compounds that form the raw ingredients for life. These include polycyclic aromatic hydrocarbons, simple sugars, alcohols, and more. Though not alive, they are chemically rich, formed in the atmospheres of dying stars or within cold clouds shaped by radiation. These tiny grains, carried across light years by galactic winds, settle into the gas that forms stars and planets. Some may have fallen onto the early Earth. The galaxy's dust is not just debris. It is a cargo of potential, drifting silently through the dark. Interstellar clouds may seed solar systems with ingredients for life. The birthplaces of stars are also the birthplaces of worlds. As planetary systems form from collapsing clouds of gas and dust, they inherit the chemical fingerprints of their parent nebula. If that cloud contains water, carbon compounds, and other building blocks of biology, those ingredients may end up in comets, asteroids, or planets. Some regions of the Milky Way are especially rich in such prebiotic chemistry. We don't yet know how common life is, but the conditions for it seem to arise naturally. The seeds of life may be scattered far and wide, tucked into the galaxy's coldest cradles, waiting for a place to grow. Some stars rotate hundreds of times faster than the sun. Most stars spin, but some spin incredibly fast, completing a full rotation in just a few hours. These rapid rotators are often young, massive, and unstable, with equators that bulge from centrifugal force. A few reach such high speeds that they fling off material, forming glowing disks around themselves. The sun rotates once every 25 to 35 days, depending on latitude. But these fast-spinning stars rotate hundreds of times more quickly, approaching physical limits. Their internal structures and evolutionary paths are different. Their lives may be brief, but while they last, they spin like sirens in the dark. The galaxy is tilted relative to the ecliptic. From Earth, the Milky Way arcs across the night sky in a graceful band of light. But it doesn't align with the plane of our solar system. The galactic plane, the flat disk in which most of the galaxy's stars reside, is tilted about 60 degrees relative to the ecliptic, the path traced by the sun and planets. This tilt is why the Milky Way rises at an angle and why it shifts position with the seasons. We are part of the galaxy, but our own little system is angled slightly askew, a small tilted boat drifting through a larger spinning sea of stars. Some stellar remnants are older than the galaxy's disk. Among the faint stars in the halo, astronomers have found white dwarfs, the cooling cores of once luminous stars that are older than the Milky Way's thin disk itself. These ancient remnants formed when the galaxy was young, before its main structure had fully settled. Their existence hints at an earlier time of star formation, a deeper history etched into the outer halo. They have burned for billions of years, slowly fading, carrying with them the quiet residue of a time when the Milky Way was still gathering its shape. The disk may be bright, but the halo remembers further back. The farthest stars orbit well beyond the main structure. The Milky Way's most distant stars orbit far beyond the familiar spiral arms. Tens or even hundreds of thousands of light years from the center. These stars move through the galactic halo on slow, wide paths, taking billions of years to complete a single orbit. Many were likely captured from smaller galaxies in past mergers, now drifting in the outermost reaches like distant sentinels. They are faint, sparse, and far between, but they help define the galaxy's size, shape, and gravitational influence. The Milky Way is not just what we see. It extends deep into the dark, shaped by wanderers at its edge. The Milky Way's shape is lopsided in several ways. Though often pictured as a symmetric spiral, the Milky Way is subtly lopsided. One side of the disk is thicker than the other. The spiral arms are uneven in brightness and extent. Even the stellar halo is slightly off-center. These asymmetries likely arise from gravitational interactions with the Magellanic Clouds, with dark matter clumps, or with past mergers. The galaxy is not a perfect pinwheel. It is a living structure marked by tugs and twists, like a spinning dancer whose skirt has been caught by the wind. Its beauty lies in that irregularity, a graceful imbalance sculpted by time. Astronomers map the galaxy using variable stars. Certain stars pulse in brightness over regular intervals, expanding and contracting like slow, luminous heartbeats. These are variable stars, and some types, like Cepheids and R. Lyrae, have well-known relationships between their brightness and their pulse period. By measuring how long a star takes to brighten and dim, astronomers can determine its true luminosity, and by comparing that to how bright it appears, its distance. These stars serve as cosmic yardsticks, helping us map the shape, structure, and scale of the Milky Way. They are lights that measure the dark, blinking beacons scattered through the spiral. The Gaia mission is revolutionizing our understanding of the Milky Way. Launched by the European Space Agency, the Gaia spacecraft is creating the most precise map of the Milky Way ever made. By measuring the positions, motions, and brightness of over 2 billion stars, Gaia reveals the galaxy's three-dimensional structure and its motion through time. It has uncovered streams from shredded galaxies, mapped the warp of the disk, and traced the sun's orbit with exquisite detail. With each new data release, Gaia deepens our understanding, turning a hazy smear of stars into a sharp, living map. It is astronomy's most ambitious star chart, a quiet revolution unfolding among the stars. The galactic plane marks a dense path of stars. If you look up on a dark night, away from city lights, you may see a hazy river of starlight crossing the sky. That's the galactic plane, the thickest slice of the Milky Way's disk. It's not a line, but a depth, a vast flattened band where the majority of the galaxy's stars reside. Through this plane, stars are densely packed, dust is layered, and star formation is common. From our vantage point, we're looking along the grain of the galaxy, peering through its richest corridors. This band isn't just beautiful, it's the crowded, humming heart of where most stars live and die. The night sky is brightest toward the galactic center. The core of the Milky Way lies in the direction of the constellation Sagittarius, a rich, glowing concentration of stars, dust, and unseen mass. From Earth, we can't see the very center in visible light. Dust clouds obscure our view, but the area glows with brightness in infrared and radio. Even with the naked eye, the region appears more crowded, more luminous, filled with the overlapping light of billions of stars. We orbit far from this center, in a quiet suburb of the galactic disk. But when we look inward, we glimpse the crowded city at the galaxy's heart. We see the Milky Way edge on from Earth. Because we live within it, we cannot look down on the Milky Way from above. Instead, we see it from the inside, a flat ribbon of stars stretching across the sky, curved only by the horizon. This edge-on view compresses the galaxy into a single arc, making it hard to grasp its full structure from our perspective. It took centuries of observation, cataloging, and mathematical deduction to realize the spiral we belong to. From Earth, we gaze through its disk, like standing in a forest and looking along the line of the trees. We do not see the shape we're part of, only the vastness that surrounds us. The galaxy holds far more than we can ever possibly see. Even with our most sensitive instruments, we glimpse only a fraction of what the Milky Way contains. Light is blocked by dust. Motion is hidden in silence. Dark matter outnumbers luminous stars. Between every star lies emptiness, and within every empty space, potential. The Milky Way is not just what we see. It is what we suspect, what we infer, what we long to understand. It holds ancient light, future stars, drifting worlds, and questions still without answers. And within that vastness, somehow, we find ourselves, one planet among many, orbiting a quiet star, floating through a story too wide for the eye. And now the stars begin to dim behind your thoughts. We've drifted through 100 quiet truths, from the warp of the galaxy's disk to the farthest halo stars, from newborn suns to long-dead remnants, from dust and gas to light and shadow and everything in between. You've wandered through stellar nurseries, danced along spiral arms, and gazed toward the galactic heart glowing behind curtains of dust. You are a part of this galaxy, not just a passenger on Earth, but a participant in its long and luminous unfolding. The iron in your blood was forged in stars. The oxygen you breathe was sculpted in ancient explosions. The atoms of your body trace their lineage to the earliest times, born from the same matter that now fuels suns and whispers through clouds of interstellar dust. Tonight, as you rest, the galaxy turns on. Stars are forming, light is traveling, silent orbits continue, and you are floating within it, a small warmth in the dark, resting in the spiral arm of a quiet, radiant sea. Let your breathing soften now. Let your thoughts drift like dust between the stars. The Milky Way doesn't ask you to understand it all, only to rest within it. You've heard the stories tonight, the collisions that built our home, the ancient stars that remember a younger universe, the invisible forces holding everything together. And perhaps somewhere in all of this, you found a strange comfort that even in a galaxy so vast, so old, so filled with violence and beauty and mystery, there is room for you, for rest, for dreams. The spiral arms will keep turning whether you're awake or asleep. The black hole at the center will continue its patient pull. Stars will be born in cold clouds, and others will fade into white dwarfs, carrying memories of times we'll never see. But tonight, none of that requires anything from you. You can simply be here, drifting, resting, held by the same gravity that holds galaxies together. Your body is heavy now, your mind is light, and somewhere above you, even if you can't see them, the stars are watching, not with eyes, but with the quiet presence of light that has traveled for years just to reach you. Close your eyes if you haven't already. The Milky Way will still be here in the morning, turning, growing, slowly colliding with its future. And so will you. Good night.